My name is Solon Spiegel. In this video, I'm demonstrating how to perform noise measurements in the RS7308 Core IC using the RSA306B spectrum analyzer. So we start by opening the software of the spectrum analyzer. So we're gonna click and open the software. And at the same time, I'm going to open the control software for the evaluation board. So we can see that we have successfully opened the software that controls the spectrum analyzer. It's indicated by the green arrow. It's connected, and my control software was done with Python language. So I'm going to press run and activate the software. So the user interface consists of three main windows. The configuration window, where you define the settings of your evaluation board. Just to remind, I have connected an evaluation board of the Core IC, where the IC is placed at the middle of the board. So this is my evaluation board. So I have set the amplitude. Mostly for noise measurement, we will be setting the amplitude value. So we may disregard the other controls. Basically, the amplitude control, it sets the value of the amplitude of the output stage of the Core IC. And what is called LNA int control, which sets the value of the gain of the input stage of the Core IC. So these two settings vary the gain of the Core IC. So this is the control settings, and the same can be addressed at the register level. You may want to configure the full register and then press update to pass the values into the board. So the actual noise setup is actually shown here. So we have Core IC PID. That's the PID for the USB board where the Core IC is placed. So this is 1002. This is for the switch. We are not using the switch board here. That's the visa address of my spectrum analyzer. So this is as a GPIB81 instrument. So the instrument state that I have already preset the instrument state is called spectrum noise. So I'm going to read the instrument state to set my initial value of my spectrum analyzer. So we have here the directory for the preset file. So that's under C, signal view PC files, user preset. So all my user preset is under this file. And this file name here indicates the output file that I'm going to save my data. So that's the name of my output file. So these are general settings that you need to configure for your to configure before running the measurements. So when you run the measurement, so the output file will take the file name and will tag the date and time that you perform the measurement. These two fields here basically controls directly the settings of the simulation of the measurements, and of the spectrum analyzer. So for this particular measurement, I would like to switch my noise measurement from 2 gigahertz to 6.2 gigahertz at the step of 100 megahertz. So this is what I'm gonna sweep values of my noise measurements. And my spectrum setup is basically shown here. So it says that the frequency is 5.3 in this initial setup. So you see here, and then you open the spectrum here, this window, and then you can see this 5.3 gigahertz is coming from this place, from this field. The 40 megahertz is my span. So I can set my span on 40 megahertz. 300 kilohertz is my resolution bandwidth. That's setting this value here. Minus 40 is my scale. It sets the top of the scale, minus 40. And 60 is not used. It actually, in this version, is reserved for an input attenuator placed at in front of the spectrum analyzer. And 64 is the average that is set in here. So you can see if I can change one value. Let's see, for example, see everything is working. So let's type 20 here, and let's see, type 5.5 gigahertz. Then I load settings and update, and you see that the values have changed here. The same if I do for resolution bandwidth, and for example, for the scale, if I press 20, just load update settings, so the scale has then moved to 20. So let's go back to my initial configuration, which is a 40 megahertz, 5.3 gigahertz, and 40 before we start the measurements. Okay. In this field here, on the right-hand side, so we have the axis. So it's going to generate the data and it's going to generate the plot once I run the noise measurement. So you're going to set the frequency, this one, and the scales of the graphs. So minus 65, minus 125, for example, is the scale of the y-axis of the noise density. Okay, so it just shows also the labels that you're going to attach to the y-axis. It's noise density and noise figure. Normally we do noise density for the transmitter noise, and noise figure if you want to look on the receiver noise. So the input loss, so it's taken into account as a factor, and then it's indicated as 2 dB. It takes into account a constant factor, that's the loss that we have in your evaluation board. So you can set this as a 2 dBs once you know that you have characterized the evaluation board, and you have an average loss of 2 dBs across the range. So you'll be setting the loss as the 2 dB at the input of the board and at the output of the board. But more accurate measurements can be done by actually loading the noise setup file, what is shown here. So let's open this noise setup file and see what is in there. So I'm going to come here in the logs, and then I have the noise setup file. And here, you can actually enter the frequency. So the first column is the frequency. The second column is the gain of a preamplifier that I will wish to connect in front of my spectrum analyzer. In this case, I'm not connecting a preamplifier, as I'm going to demonstrate the transmit noise. So this is the third column is the noise figure of my preamplifier. And the fourth column is actually the gain of my device under test, characterized under the conditions that I have defined in my setup by the gain. So this is a pre-measured gain of my device under test. So you can also add on this file, create a file, and actually add the losses of your evaluation board into this file, and which is frequency dependent, and then you make a more accurate measurement. Since I'm doing the transmit noise in this demonstration, it's not that important accuracy of plus minus half dB in the transmit noise. So I'm going to leave an average value of 2 dBs at the input and output loss, and I have not placed any amplifier, so I'm going to set here 0 for the gain and 0 for the noise of my preamplifier. So the first thing, let's close this. So the first thing that we need to do is to run one measurement to evaluate the noise floor of the spectrum analyzer. So far, what we have done here is basically make a measurement, and this is indicates on my marker one here is minus 155 dBm hertz is actually my noise floor of my spectrum analyzer at the frequency of 5.23. But I would like to characterize the noise across the sweeping frequency. So I'm going to press noise spectrum noise. So we're actually going to make one measurement to evaluate the noise floor of the spectrum analyzer. So let's do that. So I'm going to go back to load to get the loads update and then run. And you see here in the frequency that we have been incrementing the frequency at 100 megahertz step, which has been defined in this field here. Okay, so it's gonna finish. So it's finished now. Now it's in 6.2 gigahertz. So this is now completed. And the next step that I'm gonna do, once you have characterized it and make the first measure of the noise floor and save that measurement, is actually perform a measurement on your device under test. So I'm gonna just switch from spectrum noise. I'm gonna disable the button of the spectrum noise, and I press the button of create Excel file, because I will output my results on an Excel format. So once you do that, I have to do again, I have to load settings and update. So, and you see immediately that my noise floor already go up, my noise floor, because now I measure my output noise density at the output of my device under test with the gain that I have been setting on this field here. Okay. So we can set this, and then I press run frequency. And now I'm making my actual measurement. So it's important when you see the results is that my actual measurement is be high enough compared to the noise floor of the spectrum analyzer, because otherwise we'll incur errors in my measurements. So let's run more and wait until it finishes here. And let's see now, I'm gonna open Excel file. And then open, let's go browse for the file. And in the logs, FB noise, log file. And we've been done now the file on the 2nd of July. So here, 2nd of July, 9:36. So 9:36 here. So this file. And you're going to press open and actually make all my measurements here. So this is, see, for example, 0 and 0, that my preamplifier gain is set to 0. And it also displays here the compensation for the EVB loss, the noise, the gain for the EVB, and the gain of the actual device on the test by removing the EVB loss. But the most important is the noise density, is this measurement that we have here. So the first measurement that we did with the spectrum noise, so it actually shows here the noise of my spectrum analyzer at the frequency range analysis. And the second measurement that we have here, this is my second measurement, is actually my output noise of my device on the test with the gain of my device set it to the position of 6, one of the highest gain at the input stage and the maximum gain at the output stage. So you can make actually the measurement of the output noise density of your device on the test. And if you know the losses of your input splitter because my Core IC, the input of the Core IC of a transmit chip is a passive splitter. There are passive splitters on my input, and the approximate loss of that passive splitter is about 13 dB. So you can take that into account and actually calculate the noise figure of my actual Core IC without the splitters. So it's about 13 dB, so that losses. But this is actually shown how to make automatic noise measurements with the RS7308 Core IC. Thank you for watching.